For example, acceleration is a derivative of velocity with respect to time, and velocity is a derivative of displacement with respect to time. Similarly, if we have an equation f is equal to ma, that is also a second order differential equation. So for in physics, to solve different problems, we need to know how to take the derivative of a function in Mathematica. So derivative of a function. So first of all, we should know what is the syntax of a derivative. So I write here. This is the title. So I have told you how to take the give this title of the notebook. It is can go to the format and then select style, and then we can decide title. So this cell is a function, is a title of the today's notebook. So the syntax of derivative function is, we write d, capital D, then we put a square brackets, and then we put the function, and then we write the comma, and then the variable with respect to which we want to find the derivative. So this is the syntax of the function. So let's do it. For example, if we have to find the derivative of x square, then we write it like that: d, copy capital D, and then square bracket, then we write x square, comma, and then we put x. This will return you the derivative of x square. If I put shift plus enter, then this will give you the derivative of function with respect to x. Now if we want to find the derivative of a function higher than first order derivative, we can, how can, for example, then the syntax is, we write the function, right, like we write x square, then we put comma, and then put a list. For list we need a curly brackets, then we put it here. First we write the derivative variable with respect to which we want to take the derivative, then we put the order of the derivative. It will give you the second order derivative of the function. Curly bracket here. So now if I run this cell, this will give you the second order derivative of the function, and it is, let's know that the derivative, second order derivative of the x is 2x. Similarly, if we have a function of more than one variable like that, let's define a function that we have this expression, and we want to find the derivative of this function with respect to, we want to find the derivative of this function with respect to x, and one second order derivative. But okay, so this will give you the second order derivative of this function, because this is derivative of this function with respect to x. So because this e power minus at is independent of x, so this will be as it is. It will the first function derivative will be cos pi x into pi, second derivative will be minus sin x, so it will be minus here, and pi square. So this is giving you the second order derivative of this function with respect to x. Similarly, if we want to find the derivative of this function with respect to t, we put here t here simply. it will return you the derivative of given function with respect to t. So it will give you the derivative of the function with respect to t. Let's define a function, like we define a new function like that. We have defined a function, some blank variable. We can use the variable, different variable here, and this is whatever variable we put here, and it will give you the expression of exponential of 2 into variable. So e power 2 whatever is this, is any variable whatever. So let's this is a function. We define a function. We can change the variable here. Okay, so let's start. We want to for example, I write it here, func function of 0. So here I have defined a function with some variable which is equal to whatever variable I put here. It will be variable here and then e power 2 into that. So this is how. Okay, now we want to, I have defined a function. So this is how you can define a function by yourself. If I put it here instead of sign here for sin sign, then this will give you the function in instead of exponential we get the sign. So run it. So this, whatever function here and whatever variable here I put, if suppose I put some here z, then this will give you the in z, because z is equal to x square plus y square. I already defined that z is equal to x square y square. So instead of z, it takes the value of z. Okay, so this is how you can find the different, you can define different functions. I put it here, w, and then it will be, because w is not defined before, so it, now I want to find the derivative of this function. Then I will have, how will I do it? I will put d square brackets, then this function whatever name I have given it, and then with respect to what, with respect to this will give you the derivative of this function with respect to w. So we have to put the variable here. Okay, because this function w will return this thing. I write for you, and then this d will give the derivative of this function with respect to w. If I put here, want to find the derivative of this some higher derivative, then I will write it like this. This will give you the second order derivative of the function with respect to w. This will give you, this is the second order derivative of this function with respect to w. So this is very easy to define a function by your own, by yourself, and then find the derivative of that function with respect to the desired variable. Okay, note there, this negative this underscore sign is here, this underscore sign is here because to keep it blank, because whatever variable I put here, it will be stored in. So this will give you a function with the blank variable here. Whatever I give here, it will give you the function in that variable. Okay, so next is how to next is we want to find the derivative of function at a some particular values. For example, we have z is equal to derivative of the function w square with respect to w, and then we want to find the value of derivative at w is equal to 2. So we use this replacement feature that in z we have replaced z here. This is the replacement feature. This means this statement means that in z, what is that? That is this expression of this 2w, because w square, derivative of w square is 2w. So in this I evaluate here this expression 2w at that w is equal to 2. When put w is equal to 2, this will give you 4. Let's do it another example. Let's suppose we have to find this function. Again I put it like that. We'll write this like this is equal to s is equal to this, and then we want to find the uh, value of this. How we write? We'll write t is equal to no need okay, t is equal to what's s, then this backslash, then we put dot, and then this replacement equal to what we write w so here we want to find the w is equal to what? We want w is equal to, well, let's suppose w is equal to pi. Evaluate this function. What this function is? Function is this w, this function. Let's check it. Then it will be here. No, this is here. First of all, this function is differentiated for 2 times with respect to w. Then I put pi instead of w for cos 2 pi is 1, so that's why 4 into 1 is 4, and this is if I remove this bracket, no need to put it in the form of list. If we have more than one variable, you can put comma here and put it in the form of the list. So this is how you can find the derivative of any function at any given value. Okay, let's try another function. Let's suppose we have y is equal to derivative of what? Derivative of y at x is equal to what? X is equal to 0. I put a 0. At x is equal to 0, so I put x here, replacement feature, x will replace with instead of 0 I put 1 here, because at 0 it will be undefined, because this is minus power. I evaluate it. So now look here. First of all, this line has the derivative of this entire function with respect to x, because x square is 2x plus 2, and then this is minus 3 minus plus over x4. Very good. Then we put 1 here, so this gives you the value of derivative of this function at x is equal to 1. So this is how you can find the derivative of any function with respect to some particular variable. I hope